Hello again. We have already learned that a computer program is nothing but step by step instructions that we give to a computer. This means that instructions are the basic and most important building blocks in computer programming. To understand how these instructions work, I am going to show you the history of computer programming. Sit back, relax, and enjoy watching the story of programming.
Long, long ago, before the year 1800, science was booming. Scientists were making a lot of discoveries and inventions. All this scientific work required a lot of calculations. These calculations were done by humans. A person who teaches is called a teacher. Just like that, a person who did these calculations or computations was called a computer. Thus, humans were the first computers in the world. These human computers would get instructions from the scientists and perform different kinds of calculations. However, the scientists always dreamt of giving instructions to machines instead of humans. Because, unlike humans, machines can work without taking a break. Until that point, there were machines that could do just one type of calculation over and over again. But the machines could not get instructions to do different calculations as desired by the scientists. Same way, in the textile industry also, there were machines or looms that could stitch the same type of dresses with the same pattern over and over again. In the year 1800, a person named Henry Jacquard from the textile industry in Paris invented the Jacquard loom. By using this Jacquard loom, Henry was able to give instructions to change the patterns in the dresses made by the machines. To give instructions, Jacquard used punched cards. The threads would go through the places where there were holes in the punched card and stop in the places where there were no holes. This way, to make a different pattern, Jacquard used to give a different punched card. Dresses and materials made by Jacquard looms were quite the fashion in Paris for a long time. Charles Babbage took notice of this and started using the same technology to give instructions to a machine called the analytical engine. This machine was used to do complex calculations just like the scientists wanted. They would use punch cards to tell the machines what calculations need to be done. Example: addition, multiplication, subtraction, etc. Ada Lovelace programmed the analytical engine. She is said to be the world's first programmer. She saw that this concept of punched cards can be used for a lot of things, not just mathematical calculations. Later on, for need of more speed, mechanical machines were replaced with electronic machines. Here, instead of punched cards, switches were used. Switch off was denoted by a 0 and switch on was denoted by a 1. A combination of switch off and switch on would denote an instruction. The ENIAC was the first electronic computer that was programmable by using many switches. Over the years, technology developed and all these switches have been replaced by tiny switches called transistors. There are billions of transistors present inside our devices. Any action that we do in our devices or any instruction that we give in our program is being translated to a unique pattern of switch off or switch on of these transistors. So literally anything that you do, switch on an AC, watch YouTube, type something in your keyboard or play a game, everything will cause some of the transistors to be turned off and some of the transistors to be turned on. This on and off state is called the binary language or machine language, usually represented as 1 for on and 0 for off.
Now, we know that any instruction given to computers is converted to binary numbers 0 and 1 or switch off and switch on. Let us see how alphabets and numbers are converted to binary language.
Each 0 or 1 in binary language is called a bit. 8 bits together form a byte. Each bit has a value based on its position as shown in the image. To find the binary language for a number, you have to find the positions that will add up to the number and make those positions as 1. For example, to represent the number 5, you have to add 4 and 1. So, you need to make the bits in these positions as 1 and make the rest of the bits as 0. This will give the binary number 0, 0, 0, 0, 0, 1, 0, 1. Did you understand? Why don't you try to make this number to binary?
Every letter in the English alphabet has a number representation. Each computer stores a number for an alphabet by using a certain code. The most famous representation is the ASCII code as shown. However, for our activities, we will be using the table that is being shown. Hence, to get the binary number for an alphabet, we just need to find the binary representation for the number that is mapped to the alphabet. Shall we write some messages in binary? Are you ready? Let us try to write the word hello in binary language. To do this, find the binary number for each letter and write them together. Now, it is time to send some secret messages using binary numbers. I am going to show you a few binary numbers. Map each number to the right alphabets and find out what my secret message is. Come on, it's easy. Next is the most interesting part. We are going to level up by sending messages in the form of music. Are you excited to listen to the music? Here it goes.
Did you listen to the tune? You would have noticed that there are only 2 notes in the tune, one high note and one low note. The high note represents the binary digit 1 and the low note represents the binary digit 0. First, we are going to convert these notes to bits and then we are going to map them to alphabets like in the previous activity. Then we will know what the message is. Come on, let's have some fun.